All right. I don't know if you guys like planes like I do, but that's just some awesome video. Like I said, it'll tie in here shortly. So let me go ahead and continue. Little comic to get us started here. Hippies are not the same as hipsters. I guess I could probably be called a hippie at some point or whatever, because my first language was Fortran, so yeah, I don't know. I guess. So I want to, throughout this presentation, I'm going to give you some information about functional JavaScript, but also why and some stories behind it and little stories from my past and how it all ties in. And I think when I've been to talks and conferences, I've really enjoyed hearing those stories, and sometimes those help to drive home the point. I usually remember those the most, and usually come out inspired for that. So hopefully, I'm going to try and do a little bit of that. Hopefully, it won't take too much time, but I'll just want to go through a little bit. So I was back here in 86 to 89. I was the photo editor for the ILEO, for the yearbook. Also worked as a photographer for the Daily Illini. I was in ROTC in Air Force. I graduated in 89 with a bachelor's in aerospace engineering. Went into the Air Force then, went to Aeronautical Systems Division at Wright-Patterson Air Force Base. And basically our job was to advise the government on whether they should purchase new aircraft or modify existing ones. The vendors always had proposals, they wanted to sell a new one or they wanted to modify the existing one based on the new use cases that they wanted to handle. And we had to try and figure out which should be the best approach, what's going to be the most cost effective, which is going to meet the missions, and all that kind of thing. So we basically had our own software that basically we could model these aircraft kind of like a CAD system, but we could fly it through missions and calculate the aerodynamics on it, the performance, run stealth on it to determine how stealthy it was. And then we could drive this with programs so that we could vary it over time and basically come up with a nice chart. So you could basically see this was the optimum aircraft, and you could see the modified versions or the new ones and all that. And we basically used a lot of the real data from the Air Force, from other airplanes to try and, calculate the appropriate thing for each aircraft. So it was pretty cool. It was a lot of homegrown stuff. Had a lot of Fortran, so that actually paid off, having known that. I did have to do a lot of C and C++ because we were porting it from VMS to Unix, and we wanted it to be cross-platform, and so we did a lot of that. So that was great. My girlfriend got me into C++, said, you got to know about this object-oriented programming stuff. It's great. And so it turned out that some of the toolkits I wanted to use for graphics were obviously OOP-based, so I got into that. So I got to see the SR-71. That's the plane there. Come in, land. It was, it was our reconnaissance aircraft. It would fly more than Mach 3. It's really kind of classified how fast it went, but it's got the world records for speed. And basically nothing could keep up with it, or missiles couldn't get to it and everything. So it was pretty neat plane. Retired and came home to its resting place in Dayton, Ohio, at the Air Force Base Museum there. And that was about, I think it was 91, when they came home. So that was kind of neat to get to see that. Married my daughter and wife there. Been doing this for about 30 years. I was in the Air Force for 5 years, and then really was doing a lot of programming and stuff, and really liked that, and thought that maybe if I wanted to ever go on my own, that programming might be a good thing to go into, because there was a lot of people doing startups and everything with that. So I kind of switched into programming and been doing that ever since, enjoying it. Worked at a lot of companies. Worked on the MasterCard Apple Pay program, Monsanto, Elsevier, RGA. I got a small company called CoWinds where I do training in that. A lot of times I'll consult out to other companies. I'll help mentor them, come in and do conference talks and different weekend things or evening things. Cover a lot of languages now. I've done Fortran, C++, Java, Ruby, JavaScript, Go, and Rust. And pretty much focus now mostly on JavaScript and a little bit of Go and Rust these days. So I haven't really went back to the old stuff too much. But why did I show you an F15 video? It's like, this is a JavaScript conference. Well, when I was in the Air Force, one of the things that I learned as we were trying to talk about these planes and which one they should buy or build or whatever, it turns out that you design an aircraft for a mission, and then the generals are always wanting to do more with it. They want to, it was an air superiority aircraft, so like the F-15 was designed to be the best aircraft out there that, to kill any other aircraft at the time. But then they said, oh, we want to be able to do a ground strike with it. It's like, well, it's not even designed to do that, but okay. So then they would, adapt it to do that. They wanted it to fly farther, so they'd strap a fuel tank on the outside, and then, and as long as the plane was designed well, like the 15, the Eagle, you could do that. You could really, strap stuff on. You could load it up. It had a lot of power, a lot of horsepower. It had the 1.26 thrust to weight ratio, so we could accelerate going straight up. So that means you could really put a lot of armament on it and a lot of fuel, and still take off and land and all that. So anyway, so that turned out to be, what I saw in the Air Force is that the planes that were well designed then could go on and do other missions easily, and it became really valuable to the aircraft. You didn't have to buy a whole new one to do it, do things. So that was really a valuable lesson. And now they were even launching like mini satellites with this thing. This thing can go pretty high, and so they could go up to the high atmosphere and then shoot like a satellite up to a mini satellite up from it. And I just heard recently that now they're talking about F15X, which might continue the life of this thing and basically put new avionics in it, and it'll continue on. It's really going to compete with the F-22 and F-35 because those aircraft are so expensive and they're hard to maintain with their stealth materials. F-15 could keep on going here after so many years. It launched first flight in '72, so it's been around a long time. So the same thing was true with software. We design our software for a particular use case that that our boss tells us at the time, or the clients. And then the nature of software is it always changes, evolves. So the best software, I think, is resilient and adaptable. Stuff that you can easily change. You don't have to throw it away. Yeah, so just like the 15 was never taken down by enemy fire, it's been the workhorse of the Air Force. It's proved itself in ever-changing harsh battle conditions anywhere in the world. I think our software should be the same. Doesn't mean that there's, everything's been good. I mean, there was accidents. There was some training accident where a 15 hit a plane hit the 15 and actually took off most of its wing. And you can see the pictures there from the History Channel. And they actually had video of this thing landing. The pilot was, did an amazing job with it. But McDonnell Douglas, now Boeing owns McDonnell Douglas, but before it was McDonnell Douglas, they didn't even think that it's possible this plane could have flown home. They thought it was damaged on the ground, and they said no, it flew back. And so they looked at it a little closer, and they said, well, I guess with all the thrust it has, with that big wide body, it kind of acts like a wing. And as long as you come in at a high pitch like that, it could potentially fly home. And so, just like in the video, it shows bringing the pilots home. That's kind of what the plane's mission was, and it does that job really well. So our software should do the same thing. Now our software is being used for all kinds of things. It used to be, video games and small web apps, but nowadays we're powering medical appliances. We're programming things for the financial, markets. Things have to be solid. You don't want to be getting that page at 2 a.m. Your wife and your kids are going to hate you, and you're going to question your job choice at that point. But if you take some smart steps to be resilient, then you can get a good night's sleep, and you can adapt your software, and then you'll be in great demand for the rest of your career because you write good software. So how do we build resilient software? Well, all the different things I've learned throughout the years, I think functional programming is kind of one of the greatest, the most bang for the buck, I think. So there's advantages for different things, but breaking things down into functions and using a functional style really, really pays off, and I hope to show you why. All right, so let's go back in time, and this is an old project I wrote in 2011, so it's ugly, I don't like it, but it's history, so we'll start with that. This was the graphic of what it is. This was called AutoFlow, and I wrote it because I was getting into Node.js, JavaScript, and we had a lot of things that we had to tie together, and this was kind of pretty early in the days. There weren't a lot of different techniques to do concurrent programming and stuff. There was promises, but they weren't as well supported. And so we were trying to find a way to make it easier. And so this was an attempt at trying to kind of create a DSL where we could put these functions together. They could all run, and as soon as one got done, the next one, they would fire off based on if they had the right inputs, were ready and all that kind of stuff. So it was trying to wire up the things that had to be done. So anyway, this was written in an OOP style. I told you that my girlfriend got me into object-oriented programming, and like everybody else, I thought it was awesome and went off and pretty much did everything that way. This was a like a base class for their tasks. So the code had basically had, you could fire off these tasks, and then there could be different types. There could be callback tasks, there could be promise tasks, there could be different ones, and then basically the software would be able to know when it's done, and it would pass on the values that it got from the outputs here into the inputs there. As soon as they were all ready, it'd fire off the next one. Anyway, so this was just like the base class, and you've probably all seen that kind of stuff where you have like a base class and you add things on, inherit or whatever. So this was base stuff, and then obviously there was a subtask or a child task that was specifically for the callbacks, and there was one for promises, and the thing with OOP code in general, and it's long. I didn't even get to like show you, like it was like way off the screen, and there's lots and lots of files. So the thing I learned is that when you ever have a bug, now you've got to like go through the whole file and potentially other files. So if this thing inherited from another file or class or even more classes, now you might potentially have to go to that class and the previous class, and you kind of with this stuff, because the state, the data in here can be kind of changed, anywhere in these functions, they can all change the state in that. You have to kind of look everywhere, and it's kind of a mess. I mean, you might see these guys with 3-4 monitors, like mission control and at their workstations. And that could be why. I mean, it's because you got to have all these files open so you can look at them and figure out what's going on. And as I've gotten older, it's hard to keep all that in my head. I mean, what's going on? What is all this data? Where's it changing? Kind of hard. So that's there's obviously advantages for things, but it gets hard for some things. So let's see what else. What could we do different? Well, we could start with basically if we don't use inheritance, then we could at least eliminate the number of the files we have to go through, because if we got just this class, we don't have to go back to the other class to look for things. So then you could do that. You might want to, kind of define all your state in the constructor so you can at least know what's in there, because sometimes people create stuff all over the place and you don't even know what the names of it is, and it's just kind of a mess. So you could do that, but that helps a little bit, but you could still be changing it anywhere and that. So maybe there's another way altogether. So let's think back to our early days when you were learning algebra. Could we use functions? We can encapsulate operations in functions, and we can break these functions, complex functions, into smaller functions. Each function, kind of trying to do one thing. And so that really turns out that works out really well. And so let's see how we can do that. So JavaScript has great support for functions. They're first-class citizens. They can be passed around like data. ES6 even added arrow functions, which now allows you to do real concise syntax for functions. But both syntaxes are useful, and I usually use the longer form, the one with where you spell out the word function. The other one's with the arrow with the greater than, equal greater than thing. I use the spelled out one first off because it's just obvious. It's in your face. You know what it's a function. So you don't have to like look at it very closely. Because with this other one, it's like if you didn't have the greater than sign, then it's like it's just a variable. But it's like you got to look really close and. All this stuff, the parentheses and different things, so it's just kind of, so the regular function is just real obvious. So I like when I go into my code, it's just like, it hits me in the face if I know what it's doing, I know what it is. But besides that, you can also, with the function style one, the long version, you can actually order these in your file, pretty much how you want. So you could potentially put them after your use, and it'll still be able to find them in the file. So there's a little bit of trickiness with that. You can, but it's for the most part you can do that. You can basically order things how you want, and I like that. So I like being able to kind of put the functions in order. I don't have to put everything at the top. I can put it, as I'm going to use it, kind of as I'm flowing through. So it's kind of nice. But the other ones the other arrow functions are useful, especially when you're doing like small things where you just have short functions. Maybe you want to create a function on the fly. That's great for that kind of stuff. So. And stop me if any of this is, if you have questions or anything like that, I'll try to answer them and stuff. And I don't know what everybody's experience is. I'm sure it's all over the board. So, but JavaScript functions are also closures, so they can use variables anywhere in their scope. So if you have a variable, like in the top here, we have a to-dos array defined at the top of this file, and then later on we've got some functions, and it's able to use those to-dos because it's in the scope. And so if we were in a different file, then it wouldn't be able to see that. So because nowadays we're using everything in modules, and so everything's kind of encapsulated by files, so it's kind of nice to have things like that. So anyway, it's a powerful feature. We can still expose functions to control how the data is changed. And so while it's a little simpler than OOP, no object, let's see, so it's a little simpler. We can expose functions, but it's not ideal, because we still have, anything could change that anything in here could change those data. So we still have to look through the whole file. So we didn't really gain a little bit, but not a lot. So let's go further. So what if we try to just use only the inputs in the function? So what if we don't use closures? What if we just pass things in? So that's better. So we've got basically, in this case, now we have our to-dos coming in, so it doesn't have to refer to an external variable in scope. And so then we can, make changes and do things that way. So you just basically define the variable outside of the function and pass it in along with the other stuff. So that's, that helps. It works out a little better. But it's not perfect either, because we got a new programmer. He just started, and one day he decided he was once going to improve this app. So he wanted to make this better. So he went in and changed our display to-dos, and see if you can notice the bug that he introduced. It's like, well, what happened? I mean, it's just making it better. He wanted to basically, before we were just spitting out the thing from console log, and he said, no, I want to spit it out with a dash, on each one, iterate over them, and put them all in a separate line, kind of markdown style. And anyway, so he put this in the code, and basically now if you see at the end there, instead of showing 4 things at the end there, it's only showing 1 after he displays. So if you go and look at the code, basically we were mutating the data. So he was doing a todos.shift, so he was actually pulling stuff off the array as he's displaying it. And so then next time we try to use that array, it's empty. So we push another thing on, but all the other things are gone. So it looked harmless, he was just trying to do a good job formatting, and he, got a bug. So how do we deal with this kind of stuff? So that's, I actually hit something like this. It wasn't, this simple, but it was basically something I didn't think was going to be changed in the code, and it was. And so I'm stepping through this thing. I'm like, the data is perfect, and then all of a sudden later here it's broke, null pointer or whatever it was, was gone, and it was changed or something. And I couldn't figure out what's going on. I thought the compiler was broke or something. I couldn't figure out, the interpreter, the JavaScript engine. And I'm like, I couldn't figure out what was going on. And finally I realized that this somebody's function that was basically just doing something else decided to modify something, and then, so it took me a couple days to figure it out. It really sucked. So anyway, don't do it. So how do we get around this? So pure functions. So this is one of the really important things that functional programming really wants you to strive for. So basically, we don't want to try not to mutate our data. When people mutate data, then they can introduce bugs and surprises in our other code, and you're not expecting it. So if we never mutate the data, then basically a lot of those things go away. If you're passing variables around, you pass in this variable, you're assuming that the person's not going to modify anything. Then if you use that variable later, it should have whatever it had before. It's not going to be changing. It's, if you want to give, add new data to something, you return a new value, so you return a new array. The old array still has what it has. The new array, has new stuff. And you might think, oh, well, that's got to be terribly inefficient, right? It's a mess. It's like, no, it's not too bad, because JavaScript uses references, and that was kind of the thing that caused the problem in the first place. But because we have a references to these things, the data, when you create a new thing, a lot of times it just copies the reference over, and so then now you have a bigger array with a few more references, and it's really not too bad. It's very fast, so it's pretty good. Pure functions that don't mutate data and don't produce side effects. Now, side effects is another kind of thing that it can be anything. It could be like writing to a file system, it could be writing to database, it could be using time, time changes. Basically anything that's going to cause our functions to not be pure. A pure function, if you remember back from algebra, if you had certain inputs, it would always give you the same output. Now, if you don't have a pure function, then obviously, it could vary. So if it could vary by time, or it could vary by what's in the database or whatever, then it can be not pure. So if it's a pure function, it could, basically these inputs always give this output every time. You could test it that way, any way you want to do it. And the other thing is that you could cache that data. You know, like if this is a real expensive operation to calculate something, you could cache that data, and then next time you see those same inputs, you can give back the data immediately. You know, so those kinds of things. So pure functions are nice. You can really optimize them. You know, they're simple. All you have to worry about is what's coming in, and then you're basically returning something new out. And in this case, I was actually, instead of returning the original array, I'm concatenating to the end and giving you a new array. So that the original array stays in place, and the new array comes back from the concat. And then here, you know, just instead of looping over those things, you could still do other ways to loop it, but there's a nice simple thing called forEach that you can use on the array, and it basically just is designed to do side effects. But in this case, I'm not changing the data that I was working on, you know. So you could obviously you could loop on it different ways and do the same thing, but that's just one way I chose. Anyway, so now we fixed the problem, and we see that we have 4 things at the end, even though we displayed and everything, it didn't change things. So, questions so far? It makes sense. All right, so we probably do need to deal with side effects. We can't live in our happy world where we never have to do anything, right? We have to probably write data somewhere, display to the console, display to the web, to the DOM, you know, all those kinds of things. So how do we deal with that? Well, if we take some tips from other languages like Haskell, they basically, or hexagonal architecture or onion architecture, they basically recommend that you create functions that will do that side effect, whatever that is, and then you pass those in at the top. So you pass those in, and then later on you can use those functions to do that stuff later. And the nice thing is you can start developing that way immediately. So even before you write the code that hits the database, you can just create a function that is going to write the database, and then now use that, pass it around. Maybe it's just a stub, it doesn't do anything. You can do the rest of your code, and then eventually you can get to writing that function. Also later, your boss says, no, I don't want to go to Postgres, I want to go to MongoDB, or I want to go somewhere else with my data. Well, if you've got that function, you know, at the top, not mixed into your code, now you just change that one function and you can point to a different database. So now you've delayed what you have to, you know, choose to where you're going with the data. You can write to a different place in the file system. You know, all that stuff can be deferred and changed later without having to affect your code. So, so here I was showing some examples where basically I have a write to storage function. I didn't implement it yet, but I'm going to use that. And then later on in my app, I'm passing that in. And then later on in my code, I want to use that function. I just call it with my data, and I know it's gonna write the data somewhere, and then I'll go on. Same thing if you want to read, if someone, you know, do all kinds of things, so you can pass stuff in. Now, obviously, you might have lots of functions, so you're gonna have lots of parameters. You're like, oh no, that's crazy, Jeff. I don't want to do that. Well, you know, there's in modern JavaScript now, you can like create an object, and you can easily destructure and that kind of thing. And so if you do that, then you basically don't have to worry about the order and stuff. And so you can just create an object, and you can easily get those fields out of the object real easily. So I just show an example of that here down at the lower version. In this lower version, and we're actually passing in, I'm changing the operation. So in the first case, we were always adding, but here I'm saying, no, I'm gonna go ahead and pass in, sometimes I'm gonna pass in a function to add, sometimes I'm gonna pass in a function to subtract, you know, whatever it is. I mean, if you're calculating, you know, some new AI model, and you wanna calculate, you know, something with TensorFlow, you can pass that in here and pass in a different model later, you know, and you don't have to change your code to take advantage of new things. So that's kind of nice. The other thing is when you're testing, this is awesome. I mean, if you've got stuff being passed in and you want to test things, now you can just put in a mock. You don't have to hit the real database. You know, you still want to test that at some point, but for a lot of your unit tests, you can just pass in these things, different things, and test out really simply. So that really, it's really a big win. So I like this style. All right, so kind of some of the ideas around functional programming. One of the big ones is use pure functions as much as you can. That's going to really, you know, where you're only using the inputs. You don't have to look, you know, basically all your thinking has just to be within that little function. I don't need 4 monitors anymore now. I have one monitor can fit that screen. Hopefully it's not too long of a function. It'll fit, you know, if I've chunked things down into small enough things where it's reasonable, I can sit that on one screen and I can look at it and I can figure out what's going on, you know, and it's nice. There's always the same result if pass the same input, so you could cache if you want to. So there's a lot of performance things. We don't mutate data. And then another thing is if you do side effects, then try to isolate them, pass them in near the top, and then you can basically change them out later and stuff. So and test easily. My current project at RGA that I'm working on, we have a lot of code that's on-prem, on servers, and it basically does a lot of modeling for the future for insurance, estimating, casualties and things over time, and how much can be paid out and different stuff. And so we basically need to do a lot more reporting around that data. So we're going to have to do 10 times the reporting we're doing now, and so we've got 10 times the models. So we're starting to move stuff into the cloud. So we're going to we're moving things out of AWS, and we're using serverless functions a lot. So now all this stuff that you're learning about, being functional, really pays off if you ever want to go serverless with, basically functions. So in serverless stuff, you basically can just write functions, and do a bunch of, underneath they call a bunch of things, do data, do whatever, and then that function itself is what you deploy to the cloud. You don't need to build up a whole operating system or build up a container or whatever. Just that function. That's what you want. Give it to the cloud and then say I can call it. So this is pretty neat stuff. If you get in this functional mindset, you'll be ready for the future, and it's pretty exciting. And those functions can scale up, so we can run thousands of them at once, and then they can scale down to nothing and not cost you anything when they're not running. So it's pretty cool. So when to use functional programming style? Pretty much anywhere. I mean, it's my preferred style now. I try to pretty much do it. I rarely write a class or an object. I write just simple objects in JavaScript, but I don't do classes and prototypes and that kind of stuff. Now, but you might say, well, I've got code that's got OOP and whatever, and maybe I need it for some reason, and well, that's fine. I mean, you can do it in sections, parts of it here. It'll all work together. There's no problem there. And I would say, if you have something that's really been, causing you issues, then just try to work on that section in a functional style, and then you can still use it with the other things. But that, it can really help you then. If you're really having a lot of problems, you can probably nail things down better, test things better, and really get it, solidified. And really at least keep your sanity around what you're working on with that. Break things into smaller, complex functions. It's amazing the stuff you can do if you just take it one piece at a time. Okay, this function only has to do this. Now what's the next thing? This next thing has to do. And you just keep breaking it down, doing one thing. I mean, it's just, it blows my mind. And it's readable later, too. You come back into that, and you're like, oh, I got these things named properly. I can see what they're doing, and, it's good. So easy to test, so it's great. All right, so continuing with the how. How do we work with data in a immutable fashion? So I said, okay, I want you to try and not mutate your data. So how do you do that? Well, I did show you one example where you were doing an array concat. So basically that returns you a new array, leaves the old one in place. Nowadays we have a variety of different things we can use with the modern ES6 and beyond techniques. And so there's you can do an array spread. So you can basically say, I want to spread the existing array and then add one or more things at the end. If you wanted to put it at the beginning, you could do reverse that. And it's real efficient. This is actually not bad code. It'll actually compile down really, really nice. Basically does concats underneath the covers or whatever. So it's efficient. You can do the same thing with objects now. So basically the objects can be spread, the values, and you create a new object, spread them out, and then add things. And now the old object is still what it was. The new object has additional things. And then you could either create new things or override something else or whatever, and do that kind of fashion. So that's kind of nice. That makes it easy to do. And again, this is pretty efficient because in a lot of cases, if these are big objects or whatever, then they're just going to be references. So there's going to be a lot of sharing going on between these things. So it's not like you're polluting the the memory space or anything. As long as we're not mutating any of these things inside of that, then this whole thing is still immutable. So that's kind of the trick. So as long as we're always doing the right things with the data, not pushing things on or not manually modifying fields, then we're okay. So it's also really nice because when we have two immutable objects, to be able to determine that they're the same, all we have to do is do a triple equal on them. And that'll check the reference. It doesn't have to go through all the data. It could be a huge object, and as long as we've not been mutating them, just they'll be the same reference. So they'll always, so it's just a quick check. It makes things really simple for a lot of that kind of stuff. All right. So also, if you want to, like start using some of the old ES5 features, that's from a long time ago. They work. Lots of cool things you can do with arrays. So map, filter, reduce, and if you need to do some side effects on like a forEach, then I showed you that earlier. But basically, in this case, you have an array, and when you call, you can chain these things like I'm showing you here. So if you call filter, then I can pass in a function, and the function says, I'm basically going to give you each value from the array, and then you're going to return a Boolean, whether or not this should be included, whether this particular entry. And these could be values, they could be objects, they could be, whatever it is, strings, it doesn't make a difference. You could still do this kind of stuff with filter, just has to return a true false on whether you want this one in the loop. And what filter returns is a new array. So it basically took the original array, still exists the way it was, gives you a new array back, now just only with a few things in it. In this case, it's filtering by greater than 2. Oh, actually, I changed the code, so this should have been greater than 20. So greater than 20 would have been 30 and 40. And then that gives you back that, and then basically I call map. Map is basically iterates on every value, but in this case, you give it a function, and whatever you give the return of the function is what the new value in the array will be. So, so basically, if I said x was 30, then I did x plus 1, so it returns 31. So then it basically creates a new array, sticks 31 in the same position as what 30 was before, and now it's 31. And now you have a new array comes back. Again, the other array is still there if you needed to use it or whatever and all that. Then finally, if you need to, so that a lot of times that's all you need to do is you need to map something in a new array. But if you need to like change the array, you want to total it up, you want to calculate the sum, or you want to basically create an object out of it or do whatever, then next thing you might want to do is reduce. And so that gives you a lot of power there because you can basically pass in a function again. This time the first parameter comes in as the accumulator, and then the second one is the actual value for each item. And so the accumulator, if you could look down at the very kind of the bottom there, the 0, I'm passing in 0 as the initial value for my accumulator. And so then basically in this case, I'm saying 0 plus whatever the value is, and I return that, that's the new accumulator. So the next call gets the next one, and so then basically I'm iterating through and totaling these things up. So that's just an easy way of doing that. But you could do all kinds of things with this. So you could basically, like I said, you can create objects, you can basically create anything out of this that you want. You create a new array if you want it to bigger, it could have more things or whatever. But objects, arrays, reduce basically lets you change the shape of that to something else. Questions so far on any of that? The nice thing about this is, if you notice, we didn't have to worry about any kind of for loops or plus plus or checking values or doing going too far over the end, or it just automatically does it for you. It's also very easy to read, and people get used to this. They see what you're doing. It's real nice and concise, and it's a pretty nice way to do things. And it's easy to throw new things in the middle. So if for some reason you need to do something else, then you just plug another step in and go continue on your way. So pretty cool. All right, so that's all great, Jeff, but what happens when my coworkers are like mutating data and now everything's screwed up again, So, well, you can use things like ESLint. So ESLint is great for just being able to check your JavaScript, and you can run all kinds of rules that will like verify all different kinds of things. There's awesome ones that basically will basically check that you've spelled things properly, you haven't you've used all the variables, or you haven't misspelled a variable, you haven't tried to use a variable you didn't create yet. There's a lot of things like that just catch tons of errors, because it's just like typos and things like that. So ESLint is really good for that. Turn it on with your editor. It hooks up to almost any editor. So as soon as you're editing, you start to get feedback. I messed something up, or it looks good, or whatever. And then you can also run it in your CI when you're kicking it off for a build. No matter whether the people set it up on their editor or not, you're still going to run it when you check it in, to your GitHub or whatever, and then basically it'll get checked and it'll get verified. There's a plugin called ESLint plugin FP, which gives you some rules where you can say, don't let me mutate things. So then it can either warn you or throw an error, and you could still override for the particular instance. Well, I do want to mutate here or whatever. But it really allows you to work in a functional style. And so even without just using JavaScript, which normally allows you to mutate things, just by turning on this rule, we can basically say, no, I want to limit myself from doing that kind of stuff because it'll cause bugs, and so then basically I can do that. So, and there's a variety of these different plugins, so they different things, but they work good. Another thing I would recommend is Prettier, which is basically an auto formatter for your code, and it just really makes things easy as far as like having a standard format across your company. We used to do this kind of stuff with ESLint, and it would complain, you have to fix it, and and it's just like. It's really just a lot easier just to go with something like Prettier. It's it doesn't always give exactly maybe what you wanted, or but it's pretty good standard, easy to read. People get used to it, so it's I like it. It's good, and you just don't have to argue about things. It reformats it automatically as you save, and you can just configure that with your editor. And that's good. And if you want to use these things together, then there's ESLint config prettier and standard. Or standard.js is one of the kind of recommended ESLint plugin groups that has a lot of nice rules in it. But if you use the prettier standard one, then it works together really well and all that. And you could, again, you could add on the FP1 if you want. So questions on any of that? Good, it's good stuff. Definitely highly recommended. If you want to go another step and really protect your data from being mutated, Lee Byron from Facebook created Immutable.js, and so it basically implements persistent data structures. This was kind of something that I think it came out of. Well, I don't know where it came out of it. I know Clojure implemented it. It's probably before that, but that was one of the places I knew it came from. Anyway, so it kind of does a lot of structural sharing. Again, there is a lot of structural sharing anyway, but it'll go, if you have really large arrays with lots and lots of numbers, you'll probably have a little bit better sharing going on with that kind of case, or something. So there are certain situations where this could be good. It does have a little bit of, changes on how you access data and stuff. So it's not just a normal object. It's not just a normal array. So that's the thing I don't like about it. And accessing data is a little slower because it's got to go through a couple hops to get to the data. So I usually just go with the normal other things that I'm going to recommend here about doing stuff with JavaScript, and then there's some other helpers you can do. But it is a valid option, and it does have some good stuff. So you might try it out, or if you need it. But lodash, you probably heard of lodash. It's been around for a while. It it kind of was a better underscore, But basically, they figured out that they could create another interface to it, and it's actually you import or install it. You install it just like normal lodash, but when you're accessing functions, you get it from the FP directory. So it's lodash/FP, and so now all of the methods and functions that come off of that /FP version are slightly different. So they're basically immutable. So they don't. Lodash and underscore would actually mutate the data, but lodash FP doesn't. It gives you a new copy. So it keeps the old one the way it was. It also adds auto currying. So currying is if you want to be able to call functions without giving them all the parameters, then it will basically give you back a function that you can use later to provide the rest of the parameters. So sometimes that's kind of nice if you want to start out I know a few of these things here, I want to go ahead and set those. Later on I'm going to give it the final piece of data and you can call that. And so then you can kind of do that kind of stuff. So it does that as well automatically. And then they basically switch the order a little bit. So in functional programming, it's really nice to have the data last, and I'll show you why a little bit later. And so they switch the order of things and put the data last. It's a little, it's not too hard to get used to. It's just something you need to be aware of. So lodash.com is where you get to the main docs. Again, the functions there are listed for the original lodash, but then they've got a wiki guide that tells you how the FP version works. And then there's also this generated version that one of the guys in the community is trying to do, because what we need is better documentation around the functional programming version, because it's really you kind of got to figure it out yourself. So he generated something. It's not complete, but he welcomes pull requests, so we can keep that updated and stuff. And it does generate off of the original stuff. So that's probably the first place I'd go, because it shows you the stuff in the right orders, and all that, and it's still got the original comments of what it's doing and stuff. So that gist there is kind of where I go. But anyway, you basically just pull out whatever functions you want to use. In this case, I'm pulling out set and update from lodash FP, and then I'm ready to go. I'm ready to use those functions. So so that's basically this version is immutable, or access, it treats data immutably. And so we got original state up here. And then I want to basically, and the nice thing is you can, for the next thing is the path of what I want to change in the data. And I don't have to just change the top root, value or properties. I can actually go deep. So I can go down and say I want to go down into a field called B, and inside of B, I'm going to go to BB. Well, if you look, I didn't even have a B or a BB in the original object. So a lot of times the code, would freak out when I try to do stuff like this, right? But lodash doesn't care. Lodash will basically say, oh, I don't have a B, I'll create you an object with a B. And then if I don't have a BB, you know, then it'll create that or whatever. So basically it'll give you all the intermediate things that you need. You didn't even have to have an object to start with. If you start out with null or something, it would be fine with that too. It'll create an object to start with, you know. So anyway, basically it's going to go into B, BB, and then set hello. And so you can see down there, that's kind of what the result was. Original state, still the same. The new state comes out, you know, from the set. You could also pass an array of things, say, instead of using the dotted form. If you want to use an array, sometimes that's more convenient. If you want to do set things in an array or something, you can give it the little bracket 0 notation, and that'll basically drill into DDD's first object in the array and set something. You can then, let's see what I'm doing down here. 3 state. Setting, okay. And then, yeah, just basically different ways that showing you can pass in a null or whatever. So, yeah. Questions on any of that? So this is kind of a nice instant thing, so makes it easy to do a lot of these immutable data type stuff. Update is another one. So that's the other one I pulled in before. And this is really awesome because instead of just being able to set something, now you give it a function and it gives you the value that it has first, and then you can change it, and whatever you return gets put back in there. And then, but the original object is still the same. So it could have, you know, if you're doing something really deep, this could have been pretty crazy. If you tried to do this with like a spread, you might have had a bunch of spreads all over the place, and you know, it just gets, what am I doing? You know, this is really, you just say, I want to jump in here, I'm going to go down to a.count, and you know, I'm going to get the original value, and increase it and put it back, you know, and return it. So basically, I can increment things, I can add stuff to arrays that are down deep, I can, you know, whatever I want. It's pretty, you can, you know, concatenate things to strings, you know. So it gives you the original value, you return what you want to update it to. So also, if you want to be accessing some stuff, you know, a lot of times you can just go object.foo.bar.baz and get the value, right? But, you know, what happens if, again, if the object didn't exist, or if some of those things in the middle didn't exist? Now you have to write all this code. It's like, oh, I gotta check and see if this thing exists before I check the next thing. Well, if you use these getters from lodash FP, then now you can just ignore all that. It'll just give you back undefined if anything in the middle isn't there. It won't throw an error. You know, just basically give you undefined, and you can go on. So eliminate tons of code, you know, just by doing this. So here we're doing we're digging deep. We're going to go and get the B. So 1, 2, 3 will come back. Again, you can use an array if you wanted instead of for the path. If you wanted to have a default, then you can use get or, and basically then so get or my default, and then the path, and then then the original object. So that's how that works. And again, all these things with lodash FP were I guess I'm showing here, yeah, they're curried. So if you don't give them all the values, then you can give the value later, and then so it gives you back a function. You can give the values to that function later, and then call things. So it's kind of nice because you can really wrap things up and then say, here I'm going to call it this, here I'm going to call it with something else, and I didn't have to repeat all that stuff. So pretty neat stuff. Pick and omit, you've probably seen that before in from lodash stuff. Same kind of thing, gives you back a new object, either taking values from it. You can say one or more values that you want to get out of this object, or if you want to exclude certain things, you can basically do that. You can pass in a single thing or an array of things you want to exclude, and these paths can be deep paths too. So you can use deep paths or shallow, whatever. So partial and currying. So you can do some of this with JavaScript as well. There's a bind operator for functions, and there's also an apply, which allows you to kind of call things with different, call functions with data. But the lodash one is kind of nice, and it's really designed for functional programming, so you're not really worrying about the this parameter. A lot of times we don't even set the this when we're doing functional stuff, so it doesn't even don't even need that in the code. So this is kind of nice. You do pass in the function first, and then you apply whatever values you want to apply to it, and gives you back the function ready to go with whatever's remaining. So just kind of, and the same thing if you want to do it with currying, you could basically say, I want to just go ahead and take my function, run curry on it, and now I have a new function that can do the same thing. So the same thing as all the lodash ones can. They can basically be given less parameters, and then you can basically call them later with the remaining parameters, and it'll work. So that's kind of handy. All right, so before we were talking about, I wanted to have my data at the end. So why would I care about that? Well, nice thing is that a lot of things can be composed together. If you're basically taking one value and then outputting a value and then passing that into another function that only takes one value, now we've got this nice chain of things that I can pipe one thing to the next to the next to the next, and so we can do composing. And so rather than doing this all, in my code, like putting all this stuff with parentheses and everything, it'd be a mess. Now I can just basically specify, say, compose, and say the functions I want to call. Again, now compose will actually go from the right side to the left. So it's going to start with the multiply by 10, and then it's going to do the increment next. If that's confusing, and sometimes that is, you might want to use the flow. The flow is opposite. The flow is basically, it's also sometimes called pipe, as an alias for it. Pipe, where you basically would call multiply by 10 first and then increment in this bottom example. So I kind of like that one, especially if you've got a lot of things. It's just, I kind of used to top down, this is going to be called in that, and whatever. And so this gives you back a function, and then whenever you call the data, gets kicked off and inserted into the first one. The result of that goes to the next one, and so this is beautiful. I mean, this kind of stuff, you can really compose things together, just like with the map filter stuff. I mean, it's really nice to be able to just plug new things in and change things and all that. Questions on any of that? All right. Partial. Okay, here I'm showing an example of where you can use flow. I'm using partial. I'm using update. So, if you wanted to update multiple things, you could put all these things in a flow or a compose and do multiple things here all in one shot. So here I'm incrementing a value and updating an account, all in one thing, and then I'm also using partial, so basically you can just glue all these things together. And you don't need to know all of lodash to do this. You can just learn one function at a time. Every time you need something new, you think, oh, let me go look and see if I can find something in there, and then basically learn it as you go, and that's what I do. Another project out there is called Ramda, which is good for doing FP. The names are for the function. It has a lot of the same stuff. It has more things, but the names are different. So there is like a translation table if you want to convert or think about it differently, in those terms. For the most part, lodash FP served me pretty good, so I kind of stick with that. And it's a lot of people are familiar with those names, even though we're doing it in an FP style. It's still, people still get it. They kind of understand what it's doing. So I think Ramda's potentially a little harder to get into, at least for JavaScript people. And also, it's fairly early. It hasn't really been tuned for performance. They talk about wanting to do performance, but as far as I know, they really haven't tuned it yet. So I think lodash is a little more benchmarking and stuff going on there. So that's just my opinion. I think I've seen some benchmarks that showed that too, but your mileage may vary. If you're doing UI stuff, of all the different things out there, React is your functional guy. So Angular uses objects and that kind of thing. Vue can kind of do some of this, but it also has objects. So if you really want to stay functional, then React supports that. React does allow you to do classes and things, but you don't need to. You can do stateless functions, and they're basically just functions, that basically do updates. And the cool thing is that you don't have to worry about the state. So you don't have to worry about what's on the screen now. You give it the new state of what you want on the screen, you give it to React, it figures out what needs to change and makes efficient updates to the DOM for you. And so it's just basically inputs and an output, and you don't have to worry about what happened to do that. If you want to deal with state, Redux is a pretty popular thing it basically treats state in a functional way, so you can do similar things to what we've been doing here. And then Recompose is a library that allows you to make a higher order component, which is basically a component out of a bunch of components. So you can kind of glue these things together and wrap them and do lots of cool things. So that's another thing. But anyway, this was a simple React functional component here, stateless functional component. And I basically pass in orders. I'm looping over the orders. And in each case, I'm outputting a list item with the key and a name and a date or whatever. So real simple code, input and output, and it'll do what you want. RxJS, if you ever need to do stuff over time or either you got a lot of events coming in, or you want to deal with lots of data, or you want to make calls out to a lot of databases, and you want to deal with the results of those. That's over time. Then RxJS can really help you out here. I mean, you can obviously use promises, things like that, but RxJS will even let you go beyond promises. It allows you to do 0 to many type events, so data can keep coming in over time, not just one call. It still has like map filter reduce type feel, a lot of those, a lot more operators, but it can do those kinds of things. And it feels the same thing, just kind of similar to what we've been doing, I mean, it's really, you make these pipelines and you just, process one thing at a time. Other FP languages that compile to JavaScript. So let's say you're just sick of JavaScript now. You still got to run on the JavaScript engine, but you want to maybe try some other things. ClojureScript is a real popular one. It's based on Clojure, which runs on Java, but basically you can run in JavaScript now. So you can basically take Clojure and it's functional. It's got all this stuff. Elm is another thing that's kind of based. It's got like a React type thing in it, and actually Redux was based on Elm. They learned, basically stole some ideas from them. So you've got a React Redux type thing built in. One thing I don't like about Elm is it's not easy to call their library functions from JavaScript. You have to kind of wrap those in an adapter thing, and it's not perfect there. So there's so many functions in JavaScript that you want to be able to use libraries and things. So that's one thing I just really can't give up. So PureScript is a Haskell-like version for JavaScript. Reason is a new thing from Facebook, which is based on OCaml, and it's pretty neat because it basically can infer a lot of your types. So instead of having to type all these things out and say what they are, data types, it can pretty much figure them out on the fly and all that. So it's pretty neat. It's something to look at in the future. Summary, use functions. Hopefully that was clear. Strive for pure functions when they don't mutate. You don't want to mutate data and produce side effects. Compose simple functions together to deal with complex problems. Isolate side effects into functions and pass those in near the top so you can swap them out, change them later. They're all in one place. Treat data immutably, returning new objects and arrays. Use ESLint, especially like things like plugin FP to be able to catch your mutations for you so you don't be changing things. Use lodash FP and other tools to do functional style programming and make it really easy on yourself. And if you want to keep going further, there's a great talk by Rich Hickey at Strange Loop. The Strange Loop is a conference in St. Louis. It has a lot of functional programming stuff, has a lot of new ideas. People come up with new things, how to deal with data, databases, and distributed data, just all the kind of hard problems we're dealing with nowadays. Great stuff. I pretty much go in there every year and come out of there with my mind blown and trying to get my head around things. But anyway, Rich did a really good talk. It was really straightforward. It's called Simple Made Easy. I think it was back in 2015 maybe or something, but it's on the web. This link has the notes and the slides and everything, and it's just fantastic. And it's really, it applies to any language. It really doesn't. It's not specific to anything. Out of the Tar Pit is a paper where they talked about reducing complexity and trying to figure out what causes problems in software, large-scale software. And basically, a lot of the stuff they figured out was the accidental complexity from all these different things that we do, and functional programming really helps with all that and treating data immutably. So that's kind of the punchline is what we just witnessed. But Strange Loop, the conference is awesome. Strange Loop, the videos, they usually put those every year out as well. So all the videos from previous years are up there. So check those out. You'll learn a lot of good stuff. If you want me to come teach your company or whatever, then certainly give me a call, or I can help out, mentor you, get you set up on the right path, whatever, that kind of thing. And then you can go on your way. Love to work with you. Spread the word if you know somebody else that's needing things. I'll be putting the slides up on UIUC, Codewinds UIUC-fun.js, because I think functional JavaScript is fun. And that's my blog and email and Twitter and everything else. Last questions? Anything I've missed? Go ahead.
Other functional or programming languages, compile.js. You didn't mention Babel.
Oh, well, yeah. Babel basically is our transpiler. It usually takes newer JavaScript and compiles us down to old JavaScript. Yeah, which is great. Yeah, pretty much everybody's using that nowadays, so I kind of ignored that. Sorry. Yeah, you're right. You're right. Absolutely. Yeah, absolutely. Yep. Go ahead. Yeah. TypeScript is good. There's a divide among people of ideas on whether TypeScript is good or bad. If it was really flexible typing language, it would probably be good. Like Haskell is a really powerful. TypeScript gets some of the way there, but not. And that makes some things harder. So there's a divide on people's ideas on that. Clojure doesn't have any types, but they instead went with something where they could spec out the data and kind of like verify it easily, and also generate a lot of tests from it. So there's different ways of dealing with data problems. Some people like TypeScript a lot. There's other ways to get the code completion, stuff like that. So there's a project called Turn.js, which will read your code and watch how you use it and give you prompts as well, so that you can do that without all the overhead of type. But you know, a lot of people like it, so yeah. Go ahead.
Are you using Ramda for your serverless or something else?
Yeah, yeah. In AWS, the serverless functions is called Lambda, and it's fantastic. Google has Google Cloud Functions, and IBM has their thing. All of them have something like that, but yeah, very similar. But yeah, Lambda's great.
In some functional languages, I've noticed the performance differences based on the data structure you use, like linked lists or lazy lists.
Sure. Yeah. Right.
Does JavaScript support all those things? I've only used arrays.
Yeah, you know, most of the time we're using just objects and arrays, and the engines are very, very tuned for those things. You know, there are fancier structures out there, and like even Immutable.js has some of those types of things. But for the most part, I haven't seen the need for them. I guess your mileage may vary if you need specific things, but most of the time arrays and small functions, arrays, and objects just fly through these modern engines. So, yeah. Is that it? Good. All right, thanks for having me. I appreciate it.